Setting. When we perform independent trials of some chance process and record the number of trials until our first success, when we perform independent trials of some chance process, and record the number of trials until our first success, that is the geometric setting. In this case, the probability of each event is the same. So on the binomial setting, we're fixing the number of events beforehand. With the geometric setting, it's exactly like the binomial setting, except we're not fixing the number of events. We're saying, hey, I'm going to keep buying those lottery tickets until I win, right? Since I won on Monday, I can quit buying them now, right? Well, $2. Okay. All right. So I'm going to flip a coin until I get heads. Okay? Since tails never fails, I might be doing this for the rest of my life, right? No, I'm going to flip a coin until I get heads. Whereas the binomial setting would be I'm going to flip a coin 5 times and see if I get heads, right? But this is I'm going to flip it until I get heads. So there are some conditions here. Basically the conditions as I see them are bins except without the n. Bis. Is it binomial, independent, and same probability? By saying binomial, that's maybe a little misleading. Is it success or failure? There's only 2 outcomes. Okay? Because it's not really binomial. Well, it is, I don't know. It is binomial. I'm getting mixed up on my words. But success and failure. So the geometric probability formula is fairly easy. The probability that y occurs given some event, some number of events, is going to be 1 minus the probability that the event occurs to the k minus 1 power, where k is how many times you end up doing the event until you have a success, times p. So the way I see this formula, what I think, what I how I would interpret this is your failures. How many failures until you have your first success? Now, probability can't tell you when you're going to have your first success, right? But it can tell you the likelihood that the success happens by a certain number of, in the case of flipping the coins, a certain number of flips. You don't have to remember that, by the way. I just want you to appreciate what the calculator will do for you, okay? All right, the mean of the geometric random variable. This one you do need to probably memorize. Is mu sub y equals EY. So they're just saying the average is the expected, which is simply just 1 divided by p. So let's take and calculate this for flipping a coin. If I flip a coin, what's the by how many flips are we expecting to get our desired result, say heads? So probability is 1/2, or 0.5. Mu sub y is going to be 1 divided by 1/2. How many halves fit into 1? 2, right? So what this is saying is that we expect our first head to appear within the first 2 flips. By the second flip, we should have our first head. Look like you're thinking that one over. Yeah? So it's an average. On average, we expect the head to occur by the second flip. Sometimes it happens on the first and that reduces the average, right? But sometimes it happens after the first and that extends the average, you know, if you were looking at it in terms of a number of flips. So it's just 1 divided by the probability. Now, in the calculator, there's an easy way to do this. Not this. This is something you'll probably want to get in your notebook up here. But the geometric probability can be calculated at Geomet, PDF, and remember the PDF is precisely that event. So first success precisely on this event. Maybe I should say trial instead of event. I think I like that better. And Geomet CDF is up to that number, is how I want you to remember that. That's how I gave it for the other. This is the first success occurs by this event or trial. Okay, so geometric. I don't know why they call it geometric. Wish I did. suppose I could Google it and find out, but I have more important things to do, like figuring out really how big 52 factorial is, right? So let's look at a problem. This is just an example. Everybody got that down? Almost. Still see a couple writing. All right. If we flip a coin, what's the probability that we get heads on the fifth flip? So the way the book would probably ask this is probability that H equals 5, or rather, they're using Y for this, where Y is the event that you want to occur. So what we're going to do is we're going to put that into our calculator. Second vars, go to your distribution and go up. It's right at the bottom of this. So we want Geomet PDF. Choose that. There's only two things to put in. What's the probability when you flip a coin? 1 and 2, or 0.5, right? And the X value is, we want to know when what's the probability that our first desired event occurs on the fifth flip. So put in 5. So Geomet PDF, because it's an equal, 0.5 or 1/2, and what do we get, about 3%? There's about 3% of the time your first head would occur on the fifth flip. What if I asked the question differently? I said, what's the probability that Y is less than or equal to 5? This is saying that we get the first head by the fifth flip. So that's going to be a CDF. So Geomet CDF, because it's an inequality. And it's pretty high, about almost 97%. Now, does anybody see a relationship between these two numbers? Yeah, if you add them up, you get 1. That's only true because our probability is 0.5. This is kind of one of those math anomaly things. It's not going to be true if your probability is different. So, yeah, don't look at that and go, oh, well, the CDF is just 1 minus the PDF. That's not true. It is in this case, but not in all cases. So, so let's show that. Let's roll a die this time. Roll a die. Roll a die. And get a 5. So the probability that Y equals 3. So what that's saying is, what's the probability that we get the 5 on exactly the third And I probably should add first 5. So it doesn't count if we roll it before. So that's going to be Geomet PDF 1/6 and 3. Did you get about almost 12%, 11.6%? Okay. So what if I ask the question, what's the probability that we get it by 5? I'm sorry, not 5, 3. There's 2 ways to ask this question. I could say, what's the probability that y is less than or equal to 3? Or we could also say probability that y is less than 4. Since this is a discrete situation, I can't roll half a die. I can't roll a die 1.5 times or 3.5 times. There's no number between the 3 and the 4. So either way that this is asked, it's the same. It's going to be the Geomet CDF 1/6 and then 3. And about 0.421. About 42% of the time we can expect the 5 to turn up within the first